Anyway, let's go to the lab manual on page 364. Okay, 364 has got a question there, 367, excuse me. So 367 asks about what you would encounter as far as climatic zones going from north to south. So that refers back to figure 13.1b. 13.1b is it's off here. Look at me. 13.1b. Let's see if I scanned that up here. I scanned everything else, but there it is. Okay, so what they're asking about is these colors, right? And the colors on this page have a key over here. So the yellow is the non-affected areas, and the green is the seasonal snow, and the purple is the permafrost, and the dark blue is the permafrost, and the dark purple is the mountain glaciers. So going back to the question here, what would you encounter if you went from Mexico to the North Pole? And you'd start with the seasonal snow in the mountain glaciers of these Rocky Mountains, and then when you get up into Alberta, into Canada, you get into the permafrost, and when you got into the Northwest Territories, you'd be up in the permanent permafrost. Just as an aside, one of the things that's going on with global warming is the permafrost is no longer permanent. And the lack of permafrost, in other words, the soil converting to mush, is affecting the ecosystems and the roads up there. You know, one of the challenges is building a road on permafrost or building it on ice. Well, that works okay as long as you got ice under the road, but when it thaws out, the road is destroyed. That's why the Alaska Highway is gravel. They don't bother to make it out of asphalt because it gets destroyed every year. All right, well, back to question 2 on page 367. That one is asking about continental glaciations and where, if mountain glaciations can happen. And the answer is, well, yeah, there are glaciers at the equator in the Andes Mountains. They're high enough. If they're high enough, yeah, you'll get glaciers even at the equator. The next question here deals with this chart under B on page 367, and you have some data to fill in here. Now it's going to take a while to do this, so I'm going to go through the lab and then just leave an open channel for as long as you guys want help to do these exercises. But my interest is giving you the tools to complete them, and everyone will do it at different rates, so I don't want to burden you with actually plotting this stuff out right this second, but this is the solution, okay? So you're doing it in the Arctic, and you plot out the information on this table, you'll get a graph that looks like that on the right. And then the next question was, what's the average extent of the sea ice in square kilometers? So to figure that out, you have to go back to this table and add up the acres or square miles of sea ice and get an average. So what I did is I just took an Excel spreadsheet and put that in, those numbers into that spreadsheet, and calculated a total of 79 and an average of 5 or what the average summer sea ice was. So the average, you see the numbers change up and down here quite a bit. Sometimes they're more than the average, sometimes they're less than the average. 2001 was a pretty good year there. So the way that you do that is you take the numbers from the table and plot them out, and then you get an average. So the next question was plot this data out on the graph and get a best fit line through it. So the way you do that is you got the points from the graph, and then in this one on the right, I drew a red curve through it, and then the next step is to draw an average average line through all the data. So you can see that the Arctic ice has not had as much of a dramatic loss. In fact, there might be a slight increase in the Antarctic ice, but the trend for the Arctic ice is to continue to lose it. And the loss of the sea ice in the Arctic does not bode well for the penguins and the bears up there that live on the ice, polar bears. Yeah, polar bears. So the polar bears are having a difficult time adjusting to this situation, as are other animals, particularly the penguins. That's a bad deal for them. The losing of the sea ice is not such a bad deal for our good buddies, the Russians, because eventually, and they've already run some ships through there was this thing called the Northwest Passage. And this was an effort in the 18th and 19th and 20th centuries to sail along the north edge of Asia. And that was possible for a short time back in the Middle Ages. Well, what happened, you would take a boat from Sweden to Kamchatka, and moving goods and services by boat is a very inexpensive way to move cargo. So it's a coveted shipping lane. And anyway, this will be a big boon to the economies of the countries that live or have land in the north of the Arctic Circle. That brings us on over to page 268, and we have 8 questions, 3 to 8, and reflection question. So question 3 is based on your calculations. Would you say the amount of Arctic sea ice as measured in September is decreasing, or staying the same? Well, the answer is it's decreasing. as we can see from this chart. And so what the next question is make a prediction based on the extent of the sea ice in 2020. So this is a projection, okay? You can draw lines and graphs and such as far as the data goes. And where the data doesn't go, you got to exercise assumptions. And so we just assume that this trend would continue along this trajectory. So the step to answer the question is to extend the line of the projection through the known points, and where it intercepts the axis there at 2020, you can read that over there and say, well, it looks like the sea ice is going to drop down to 3 million square kilometers. That's the step we do there. And that's how you answer that question. You can extend it down and project it and read it off the graph. And we'll get that 3 million square miles. So the steps are, you go back to this table, plot the table on these graphs, from this table on these graphs, draw the line, extend the line, and that helps you answer those questions. So I've kind of gone through the step-by-step here, showing for the Antarctic. The Antarctic, well, like I said, it kind of looks like the Antarctic might be increasing a little bit from 32 million to maybe 37 million. So I put it to you, why is that? Why would the Antarctic sea ice be increasing and the Arctic sea ice decreasing?
Because it's not just a change in the, it's a change in the global weather, but it's not just a change, it's not just a, it's like a reversal of the poles is starting to happen.
There's a lot involved, isn't there?
It's not just that everyone wants to say that there's global warming going on, but it's not just that. There's a change and there's a shift in the actual weather patterns from not just in one from in all the different regions, there's a shift actually occurring. So some places are actually getting warmer, but other places are actually getting colder. It's just a shift. Yeah,
there's a lot of things to be think about. One of them is this: just why does a glacier increase and go further down the valley? Because it snows more. Well, why does it snow more? Well, it's because of more precipitation. Well, why is more precipitation? Because there's more evaporation. Well, why is there more evaporation? Well, because it's warmer. So in some places in the Earth, the thermocline's affected, the distribution of the land masses, the warming has increased evaporation, so you've got more moisture in the atmosphere, in the southern hemisphere. There's a lot of things that play together to cause that change. So at any rate, but you're right, Miss Weatherman, that it is a complex thing involving several variables. And so there's no simple, one answer doesn't fit all. I guess it's caution to, really, that's true for anything.